Thanks, Heike, and welcome back for session number 3. I'm glad to be here. So just a quick recap on what we've covered so far in the previous 2 sessions, which happened last week. We did session 1 on Tuesday last week, and we covered an introduction to the ITDR platform and a prevention overview. And then on session number 2, Wednesday last week, we dove into the detection part of the platform. And today, I must say, it's my favorite part of the webinar series. It's all about investigation and hunting, and I think you're going to enjoy today. There's lots of really cool capabilities that we have on the hunting side, and lots of data we can visualize and bring up, and it's quite an interesting topic for a security analyst. So with that, day number 3, we're going to cover a little bit around some of the UEBA type capabilities we have with investigation priority, and a little bit around how to investigate an incident. So I'll cover that first and go through what those capabilities are, and then we'll spend the back half of the hour going through hunting. Got some examples for you. I'll sort of explain a little bit on how to use the hunting tables. It's not a KQL 101, but I'll try my best to sort of make it accessible to most people on the call. And then if we have time, I can just briefly talk about custom detections as well, and how you can create a custom detection. So with that, I want to talk a little bit about something called investigation priority score. So if you remember the previous session, we spoke a little bit about detections within the identity platform, and we specifically focused on Microsoft Defender for Identity, and we spoke about a number of different detections there. I think we honed in on the pass the ticket detection. So at a sort of product by product level, we have this ability to fire different alerts or different detections on things that we see, and they get surfaced up into the Defender XDR console, as you saw last week. We then have this concept of incidents where we can correlate alerts together, and we spoke a little bit about the correlation technology last week. I'll show you an end-to-end incident today, and how you might go around investigating that, and how the incidents are how the alerts are correlated into the incident. But one thing that I want to just pick up on first is this notion of investigation priority. So within the XDR service, we have this capability whereby we can have a look at specific alerts or specific behaviors that a user is doing within the environment, not just on-prem, but also across cloud services as well. And we do this through our Microsoft Defender for Cloud Apps product. And we can create a score, if you want to think about it as almost like a dynamic score on how risky that user is. And we call that investigation priority. So the score itself is sort of on a user by user basis. The higher the score, the more at risk that user would deem to be. Now, the risk score is made up of both alerts that are associated with that user and any risky activities. And a risky activity might be something that is not high fidelity enough in and of itself to fire an alert on, but it's something that's an interesting artifact that might indicate that the user is doing something that's out of character for themselves. So we can have a look at those alerts and those risks, and then we can surface those into the timeline of the user, and then in the timeline of the user, where there's where appropriate, we will score those activities and those alerts, and then they will increase the user's investigation priority. So just to talk about this a little bit, you can see here at the bottom, these are the activities and risks which are making up this particular user's score. And we are showing or calculating the score based on the last 7 days worth of activity. Now, I guess the reason we're doing that is to make sure that the risk score is always fresh, right? We want to make sure that it's got the latest alerts and the latest activities in there. So it's like a rolling score over the last 7 days that gets surfaced up into the console here. We also see on the user page, and I'll show you this in the console, but on the user summary page, all of the alerts and incidents that are associated with this user. We'll just zoom in slightly over here. You can see the investigation priority over the last couple of weeks, and you can see that this user's investigation priority has jumped up in the last week or so, and is now at some level since the activities and risks that we've seen. And then we can see here just this one here, which is the user's score compared to the rest of the organization. So the higher the user's score is compared to the organization, the more at risk they are than other users, so to speak. There are also some other properties here which may be interesting for us to look at. We can see, all of the UAC controls for that user. There's a number of different attributes and metadata on this page that are interesting for us. Now, when we investigate an incident and we go into an incident, and again, I'll sort of show you a little bit of this during the demo. Part of the incident we spoke about was to correlate alerts into the incident, but another big part of an incident is we want to understand what the scope of an incident is as well. So with the scope of an incident, what we are looking at doing is identifying the users, the devices, the mailboxes and such that might be part of this particular incident, and then we can surface information about that up into the console. And you can see in this screenshot here, we've got a number of users who are in scope of this particular incident, so they have some alerts or activity associated with them. And we have the investigation priority listed on the right hand side here, and we can then sort that investigation priority against the users that are within scope of the incident. And you can see that in this particular one, Jonathan is the user that's deemed to be most at risk. So that might be where during an investigation of an incident, I want to focus my efforts in terms of remediation, because that user might be the one that was subject to the initial compromise, let's say. We spoke a little bit last week as well about the lateral movement paths, but just to sort of showcase this, because I think it's quite interesting also, within the Observed in Organization tab within the Defender 365 user page, we can see all of the devices that the user might be logged into. We can see the groups that the user is a member of, and that's interesting for us again to understand, are they a privileged user or not? And then we have this lateral movement paths visibility as well. So in this particular example, we can see again Jonathan is the user who is the source or the path initiator of this risky path. And then with this risky path, if Jonathan was to be compromised, then Deborah, who's logged into this same machine that Jonathan's logged into, could also be compromised, and then her credential used because she's a member of this help desk group to then pivot over to this machine where Nesta is logged onto. So again, we're trying to surface up as much context and as much information as we can within the console. So with that, I'll jump over to the demo environment quickly, and giving away my hunting tab there a bit too quickly. So I'll just go to the incidents tab within this particular tenant. So if you remember last week, we spoke a little bit about the alerts, and we went specifically into some alerts on Defender for Identity. What I want to show you is just very briefly what an incident looks like and what we can do when we're investigating an incident, like how would we approach an incident investigation. So we can see here, I've got this this top incident here. This is the one I'm going to click. So if I open this up, and I think I did show this briefly last week, but just to sort of show this in a bit more detail. So in this particular incident that we've got going on, this is actually an adversary in the middle incident, whereby an attacker has managed to compromise a user's token through some phishing or some credential phishing, and then use that token to get broader and deeper access across some of the cloud services. So this is actually an identity-based attack, more on the cloud than it is on premises. But we can see here in the incident, we have our attack story on the left-hand side here, and I'll show you a little bit in a second how we can use this attack story. Some of the alerts aren't quite in the right time order, and there's a reason for that, but I'll just sort of mention that as we go through. And then we have this attack graph in the middle as well, which is quite useful for us if we want to go through and identify particular alerts. You can see as I hover over the alerts on the left here, it highlights the particular nodes on the graph. So these are all pivotable items in here. I can drag items along. I can also change the layout as well. This one's quite nice if I align by entity types. what it will do is it will just reorganize the graph for me and then show me the different entities on a lateral plane. Hopefully, if it goes, live demos always very quick. Doesn't want to work for me today. Try one more time. Okay, no worries. It doesn't want to work today. So I'll just show you on this side here. I can also ungroup similar nodes as well. So by default, what we're going to do is, if I zoom in on the graph here, we are going to group like similar users together, similar IPs together, and so on. So if I click that button there, you'll see it just sort of simplifies the graph a little bit for me and just allows me to have a little bit of a better visibility on that. We also have an incident summary on the right hand side here as well, and we've got some recommendations that we can follow. We've got some related threats that could be analytics reports that based on specific TTPs or threat actors that we've seen within this particular incident. And then of course we have the incident details. We have the entities in the summary view here, and a bit of just high level information. We're going to go into a little bit more depth in these tabs here, which is more information than what's detailed on the right hand side here. So as I'm investigating an incident, there's the attack story here is built out by the alerts that have been correlated into an incident based on the time that the alerts were recognized by the system, so to speak. So as the alerts fire from the different products, so MDI might fire an alert, Microsoft Defender for Cloud Apps might fire an alert, Microsoft Defender for Endpoint might fire an alert. As these alerts are firing, the correlation engine is working in the background at the XDR level to identify where those alerts might be related. And then where those alerts, where we believe they're related, we will correlate them into the same incident, and then we will organize them on the timeline based on the time that alert happened. And if you remember last week, we spoke a little bit about the correlation logic and how that correlation logic works. And you can see if I click on one of the actual detections here, this first one, which is activity from a Tor address here, I get details about the detection. Now, this is a detection from Microsoft Defender for Cloud Apps, actually. Yeah, Microsoft Defender for Cloud Apps. You'll see the alert structure is similar to the ones that we looked at last week, but it's a little bit different because it's from a different product. And we see the information about the alert. We see all of the activity data that is interesting to be part of this specific detection. And if I scroll down here, you will see a little bit of information in terms of why this alert was correlated into this incident. So you can see we've got same user credentials here based on the UPN, and I think that's based on either the GUID or session identifier for that user. And we've got similar IP addresses there as well. So that's like part of the reason why this alert was correlated in, and each alert will have a reason in here, a linked by reason as to why it's part of the incident. Now, there might be a question from people that would be, well, how can we, if maybe an alert wasn't correlated in, can we correlate alerts in ourselves? And the answer is yes. You just go into the alert specifically. You can go into the properties of the alert, and then you can say link to this incident, and for whatever reason it's not been correlated in, or it's maybe a custom detection or some like peripheral detection that didn't make sense fully for us to correlate, you can actually absolutely bring it into the incident. And when you bring it into the incident, it actually kicks off the correlation logic again based on the data that it's brought in, and it will try and identify any broader alerts that might be relevant, or events that might be relevant to bring into the specific detection here. So in this particular incident here, again, the alerts are a little bit out of order, but what we've got essentially is a user who's had a email message delivered that's potentially benign at point of delivery. So it was like a non-activated link, so to speak. They've delivered that email message to a user, and then the user has clicked the link in the email, the malicious link in the email, and then they've given up their credentials to a phishing website. And what's happened subsequent to that is the attacker has then used or stolen that user's token, and then used that user's token to go in and do things like create suspicious inbox forwarding rules against that user. So these are the types of things that we see attackers doing as they go through their particular MO as they're perpetrating an attack. So if we look here, we can see the actual email message itself. And again, this isn't strictly identity related or ITDR related, but it is part of the context of how the XDR and ITDR as part of the XDR is bringing together all of these signals from all of these different services. So we've got an identity-based attack that's actually leveraging signals from the email service or signals from the cloud app service, etc., etc. So in this particular instance here, we can see we've got this message here. I can click on the specific item there, and I can open the email entity, and it will actually open a new page for me. Take me to that new page where I can actually examine the email itself. Again, I'm not going to go too deep into this, just in the interest of time, but just to give you a view of the sorts of things that you can get from an investigation point of view within the XDR service. Just give this a second to load. So we can see a lot of metadata about this specific email. We can see that our latest verdict was that it was a phish threat. So we've reclassified it as being phish. We can see that originally it was delivered as no threats on the email, and we can see that the reason why it's being classified as phish is through our URL detonation reputation. So as the users click the link, we've actually identified it as being malicious at point of click. You can see a timeline there of the particular delivery of the email flow. And if I go into the analysis, you can see, again, a bunch of metadata about the email. These are all, very interesting from an investigation point of view. I've got all the email headers and such that I can dig into. But if I go to the URL, you'll see, hopefully there's a URL in here. And if I click on this URL, you can see, I just want to show you the sorts of details you can get. So as the users clicked the link, or as we've detonated the link, I should say, what we've actually done is we've captured a screenshot of the actual website that the user's gone to. And again, if I just click on this here, open up the screenshot, you'll see that it looks very, very, very similar to a Microsoft sign-in page. Now, it's not actually a Microsoft sign-in page, it's a phishing page, made to look like a Microsoft sign-in page, but something that would very easily trick users if they were to put their credentials into there. So ultimately, the user's been phished, they've entered the credentials into this particular website, and if I just go, just flick through to the right one there, I see all of the contacted URLs in here, and there's a lot of redirection in the URLs, which has then led to the actual email popping up there and the user submitting their credentials. So again, just flip back over to the right screen. Yeah, so we can see the sort of email message, and then once the user's got access to, or once the bad actor's got access to the user's token, you can see here in the suspicious inbox forwarding rule, this has been tagged as an alert by Microsoft Defender for Cloud Apps. So we're looking at all of the user activity data across the cloud services. So again, this is really identity related, right? We're looking at what this user is doing, not just across Active Directory on premises, which MDI is picking up, Microsoft Defender for Identity, but also across Exchange Online, SharePoint, Azure, all of those other services as well. And we can see here, if I just scroll down, I've got all of the details that the bad actor, in this instance, I know it's a bad actor, has accessed this user's online account from a Tor address, which is suspicious, and that correlates obviously back to this previous alert here. And then inside here, I can see a number of things that were done by this particular threat actor, and one of those things was to create an inbox forwarding rule. So if I click on this here, I get a bit of metadata about this detection on the right hand side. You can see I've got some activity objects here which are sort of surfaced up, but what's interesting for me is if I go into the raw data here, and in the raw data I can actually see it's like a JSON representation of what's come out of the API effectively in terms of the activity details. And you can see here that there's an inbox forwarding rule called IT cleanup. It's looking for things, these particular keywords, so password or transfer or bank or account, etc. And it's going to forward the email to this, in this instance, non-existent email address out there. So you can see now that the attackers managed to phish the user. They've created this inbox forwarding rule. I've got a number of events from Microsoft Defender for Endpoint where the user's connected out to this suspicious phishing domain. You can see the outbound connections from Microsoft Edge here coming in. And then you can see ultimately that the link was clicked, the credentials submitted, and then I've also got here, which is interesting, just as a side note, this is actually a Sentinel detection. So with our unified security operations platform now, we can actually bring in detections from Microsoft Sentinel and correlate them in to incidents as well. So this is actually from a proxy log, and in the proxy log, we've seen the connection out to the malicious URL, which is the one that's hosting the phishing web page. So the attack proceeds anyway, and there's a bit more detail within here. The attacker manages to leverage that credential and then looks to go and plant some malicious assets onto a blob storage container. So we're actually pulling in information here from Defender for Cloud, the Microsoft Defender for Cloud as well. So I won't go any further into sort of the incident investigation. You get the idea in terms of how we're building this up and how you can go through and leverage the different parts of the incident here. Now, a lot of the one point I do want to make here is a lot of the detail that we're interested in is actually just surfaced directly in this web page here. Now, I did pivot out a little bit, but I maybe didn't need to do that pivot out. Right, there's a lot of rich information that's available to me right directly within the console here. As I click the detections on the left-hand side here, just to show you again, you can see I get the details of the detection there. I get an overview of the detection on the right-hand side here. I also have our assets within here as well. So I can click on like the user here, Sonia. I can click on the user details, and I actually get visibility of the user details on the right-hand side as well. And we can see that investigation priority score that I was talking about before. And you get some metadata about the user. Now I can go directly to the user page from here. That is doable, but I just want to show you a little bit of the rest of the incident construct. So if I want to, I can go into the alerts list here. All of the alerts that are part of the alert story are listed in the alerts page. So if I wanted to, I can come in here, I can filter in here, I can add a filter for certain detection sources, and I might want to filter, just to show you maybe the inbox one. If I search for Defender for Cloud Apps, you can see I've got two specific alerts there. One is the Tor IP address, and one is the inbox forwarding rule. But I can add filters for many other types of properties there as well. I can also sort this list if I want to. So I might do that if I'm going a little bit deeper into the investigation and I want to identify specific types of alerts and so on and so forth. Then I have this assets tab, which is the one where we're trying to understand the scope of an incident. So within this assets tab here, I can see the devices which are part of this particular incident, but I can see the user, and the user in question here is the user that unfortunately submitted the credentials, which is Sonia. And again, you can see I have the investigation priority listed here, and it's automatically sorted. If I had multiple users within this incident and they all had a different investigation priority, I could sort this list and then I could identify that particular user if I wanted to. And again, I can click on the user here, I get that same flyout on the right hand side, and then I can go to the user page, which I'll do in 1 second. We also have, just to sort of wrap up a little bit on the incident construct as well, we have this concept of investigations or automatic investigations and attack disruption, and we'll talk a little bit about that in tomorrow's session. So I will go into a little bit about response, manual response, attack disruption, and how that comes to bear within the product. But in this particular incident, there's a couple of automatic investigations that have been kicked off from Microsoft Defender for Office, and that's to do with that malicious URL and that email that was delivered. We also have a view of all of the different assets which have been identified within the incident as well, and then we can make a determination as to whether these things are malicious or not. So you can see there's a number of things like emails and URLs and IP addresses, and if there was files, there would be files in there. Any particular entities that are part of the scope of the incident, and I can see how they've been identified from a verdict perspective.
Chris, there's a question, and I think it would be good if I raise it right away.
Yes,
so
let's go.
Can you show the website screenshot page again, tied to this incident, because the person would like to see this in their environment, but the incident does not include the screenshot. Did you have further submit them for analysis prior to viewing the screenshots preview?
Oh, you mean in the email? So that relies on Microsoft Defender for Office. So you're talking about this bit here, yeah?
I don't know. I think so. I only got that question.
Yeah, so it's talking about the screenshot capability in here. Just to flick over. So in the URL here, I've got the URL listed, and when I click that URL, I get this flyout page, and then I get details here, and part of that details is the screenshot. Whether or not this is populated will depend on a number of things, right? So for one, this is coming from Microsoft Defender for Office. I just want to make that pretty clear. Now we have Microsoft Defender for Office in this demo environment. Of course, it's got the full XDR suite. Therefore, we have all of the advanced capabilities of Defender for Office, which includes the URL detonation. And the bit that's capturing that screenshot is where the URL is detonated by the service. So typically we will do that either at point of delivery or potentially at point of click by the user. And at point of time of click of the user, we will do an inline detonation, and then where we might identify that as being malicious, we will capture artifacts about that. And if we have and can capture that artifact, and we can't always, just to be clear, it's not 100% infallible, then we will capture that screenshot and put it in there. You'll also see things like if there's an attachment in the email, we can do a deep analysis of the attachment as well. That's something that might pop up in this particular view as well.
Perfect. So you were spot on with answering the question in the right way. So thank you very much.
Perfect. Thank you. Okay. So right, just in the interest of time, what I'm going to do is flick over to the user page, because I think that's probably going to be the next interesting bit that I can show you before I then get into the hunting. So if I go to the user page here, and again, I sort of showed you this in the slides already, and the slides were actually built from this user from an investigation priority, so it shouldn't be too dissimilar. But this is really, really useful for us to start to dive deeply into a user as an asset, and then identify whether this user is actually compromised, whether they're at risk, whether there's anything that we need to do, like more remediation or investigation for this particular user. So I've spoken already about the investigation priority. It's pretty self-explanatory based on what I've already said. These are the alerts and activities which make that up, and you can see we're split between 75 points coming from alerts and 25 coming from activities. Where it is an activity one, you'll see that there's actually a hyperlink there. And if I click on that, you'll see that the reason this has been surfaced as a piece of evidence is because it's the first time the user's connected from that specific ISP. This is an actual alert, which is why it's got the priority there. Again, there's another logon event there from a different ISP. And then we've got some activity from a Tor address. And then we've got more. In fact, this is a risky activity here where we've got connectivity from a new country and connectivity from a new ISP as well. So you can see like how we're profiling that user's activities and surfacing that up into the console here. Now, if I go into the observed in organization, again, I can look at things like the groups the user is a member of. from an Active Directory point of view, this is going to be quite interesting for us. If the user is in domain admins, let's say, then potentially they're going to need some investigation more quickly, right? They're going to need to have remediation applied probably more quickly. So we're getting a little bit of information about the user here. We can also see the countries that the user's connected from, and again, you know, the Netherlands as an example is surfaced up there because we saw that in the activity that I was just showing you a second ago. But the bit that I just want to finish off with on here is, and I sort of spoke about this I think last week, where, you know, ITDR applying that concept of EDR to identities, where I get visibility of all of the users' activity on this timeline here, where I can go back in time, regardless of whether that activity is suspicious or malicious or not. I can actually sort of go back in time and I can see all of the activities that the user has done. Now, in this instance, the attack scenario was run very recently, so a lot of the most recent stuff is actually malicious. But you'll see there's, you know, just all different events here coming from both, you know, Active Directory, coming from Microsoft 365, which is effectively Entra, coming from Office 365 services. There's a number of different activities there. I can filter the activities on this timeline here. As an example, I can filter on activity type, and I could just say, show me all of the logon success activities. And if I apply that, that list, by the way, is the filter that you get is based on the activities that are in the timeline. So that's why I don't see everything, but I can come in here and I can see, and I just want to show activity data rather than alerts. So user activities, and then I can see here all of the user logon success activities for this particular user, and you'll see, you know, most of these are from Active Directory in this instance here. So there's a way that I can sort of investigate a user. I can sort of, you know, apply different filters. I can look for, you know, different things. I can export the timeline as well to make it a little bit easier maybe to filter and search on. And I can go back, I think we support now up to 180 days, but when you go back in time, we'll only show the timeline in chunks of, I think, 7 days at a time. So you can come in here, you can set a custom range, and then you can set a custom range on a 7-day period, effectively, going as far back as 180 days is the case there. So yeah, really interesting for us to be able to sort of do this and dig into this. Now, all of this data is actually available in the hunting tables as well, but in the hunting tables, it's only 30 days worth of data. So that leads us nicely now into hunting, and I'll show you some of this for this particular user, some of these activities and how you can surface them up if you were to do a deeper investigation. Heike, any questions before I dive into the hunting bit? That would be a good.
So I think we can ask that question also. I think someone is already answering, but for the scenario that you just showed with all the different alerts in that incident, what licenses are required? Is this, do we need all E5, or was it something with Entra, Microsoft Entra? Was it Office? So can you explain, please?
Yeah, I can. So I guess the amount of richness you get in an incident is a direct correlation of which products you have licensed, is probably the way I would say it. So if you have Defender for Office, and if you have Defender for Endpoint, and if you have Defender for Cloud Apps, and if you have Entra ID identity protection, if you have all of those things, then all of those things are going to be firing detections into the console and activities as well. And then depending on you know, what activities are being performed, we're going to correlate those things together. Now, in the incident that I've just shown, you know, some of it was coming from Office. Like if I didn't have Defender for Office in the environment, I would still get the alerts from Microsoft Defender for Cloud Apps, and I would still get the alerts if I had the EDR, Defender for Endpoint, and they would be surfaced up. I just would be missing the email context. And, you know, quite frankly, that's the power of the XDR. That's the power of, you know, how the E5 security suite is bringing together, you know, those historically siloed solutions into a solution which is giving you that context and correlation and visibility across all of those things. So I guess it's a bit of a woolly answer, and I don't mean to be that way, in as much as, you know, what the value you get out of the solution depends on which licenses you've bought. Like if you've only bought MDI and Entra IP, then of course we're going to show you detections from there. We'll correlate where appropriate, but you're not going to see all the EDR context. You're not going to see all that, the rest of that context there, right? So hopefully that sort of answers it.
Yes, thank you.
Okay.
And the other questions I will get later on because they would go back to Office. So let's stay for now in the demo and then we do them later.
I did have a couple of slides, but actually what I'm going to do is I'm going to flip straight to the demo and we'll just go from there. Okay, so the hunting console is in the investigation and response blade on the left-hand side here. In fact, there's probably just one slide that I want to show just to set a bit of context, which is this one. So hunting is based on activity data that we store in a set of tables, right? So if you're familiar with like log analytics and Custo, it's that same type of concept. It's effectively a data store where all of the activity data gets sent into. Now you can see in this instance, these are what I would call the ITDR related tables. So there's a couple of tables here which Microsoft Entra populates. The cloud app events is also populated from mainly Microsoft Defender for cloud apps, but there are also other products which do contribute to it. And then we've got all of these identity tables here around directory events, logon events, and query events, which are mainly populated from Defender for identity. But again, there are some events in there from Microsoft Entra ID as an example. So when we're talking about hunting from an identity perspective, these are the tables that we're really looking at digging into, and predominantly these are the ones that are going to surface up the interesting artifacts from an identity perspective. Now, the way that we query the tables is through Custo query language, or KQL. So KQL is just our query language that we use for this. We use it for Sentinel, we use it for log analytics, we use it for a number of different services. And you can see here just an example KQL query there. Effectively, it's a SQL-like language where we specify the data that we want to search into, and then we specify a set of parameters after that in terms of how we filter and sort that data. And we'll show some examples in a second. Now, there are a number of other tables which, again, based on that licensing question, will be populated based on which products that you have deployed. So if you deploy Microsoft Defender for Endpoint, then all of these device tables are going to have data in them. If you deploy Microsoft Defender for Office, all of the email tables will, and so on and so forth. So again, the more tools that you have deployed, the more data that you're going to see, and the more visibility that you're going to have into the environment at a native level. And I think that's important, right? We're not shipping the data out to any third-party source or service here. This is all built into the license cost. It's built into the service directly in terms of how you interrogate it. So with that little quick scene setter, I've got some example queries here that I'm going to dig into. In fact, before I get there, I want to just show you this. Not that one, sorry. This one. Okay, so I want to show you the identity info table. So the identity info table is effectively the table which contains all of the identity profiles that we've identified. So if I just run this query here, I've put a little bit of pre-filtering on. Oh, sorry, let me just run that again. I've put a little bit of pre-filtering on here just to make sure I'm only returning our demo users within this environment. So what I've done here is I'm just looking in the identity info table, which is a table that contains, as the name suggests, all of the identities within the environment. I'm applying a filter here to only search for the domain, which is our demo domain, and then I'm just making sure that I'm only returning the latest version of that identity, which is what that bit's doing there. Now you'll see the type of information that we have. We've got like names, we've got domains, we've got distinguished names where they're relevant. We've got where who the source provider is. Are they purely an on-prem user? Are they a hybrid user? And then we've got other tabs here, other tags here on the right-hand side as well, such as whether they're sensitive or not. Now we tag them as sensitive automatically based on them being in one of our sensitive groups. So if they're in domain admins or one of the default groups, we will mark them as sensitive. If you mark one of your own groups as sensitive, then of course we will then tag the user sensitive if they're in that group. And we also have here information coming from Microsoft Entra ID as well, which is the actual assigned roles for the Entra ID roles for that user. So where relevant, I can actually see Entra ID specific roles as well. So what I'm going to do is I'm just going to show you, I can filter this here a little bit more. So I'm just going to say, right, only show me the users which are deemed to be sensitive. And then I'm only going to return users which have a UPN. Now, there are, in some instances, users that don't have a UPN where they're like built-in users. So I'm just going to filter those users out there. So now I've got a list of users who are deemed to be sensitive users in my environment. And if I scroll over, you'll see they've all got this sensitive tag associated with them. Now, that's fairly useful in and of itself. But what would be more useful is actually if I start to work on this query and I can say, right, what I want to know is actually what all the logons for these users are, because these are sensitive users, right? I might want to track those logons across the environment. So one way that I can do that is I can create effectively a variable with this data. So I'm going to use this let command here. So I'm going to create a variable called sensitive users. And what this variable is going to be populated with is the output of the query that we've just run, which is effectively the list of sensitive users in the environment. Now I just need to put my semicolon in, otherwise the query won't work. And then what I'm going to do is I'm going to look in the logon events table. The logon events table is the table which contains all of the logons for all of the users across the environment. So I'm going to look in this table here. I'm going to look specifically for Kerberos-based authentications, where it's an interactive logon or a remote desktop logon. So I want to look specifically at the interactive usage of credentials being typed into a console, which would then expose them in the memory of the machine, which could be used for credential theft. And what I'm going to do is I'm going to join the output of this table using this join command here with the output of the variable that I specified here. So effectively, it's applying a filter whereby I'm going to filter the results of the logon events to only contain events where the user is tagged to be sensitive. Now, if I run this, I will get a list, hopefully. Just run it again. Sorry. Sometimes when you click it, it highlights like one line at a time and not all the lines. There we go. So you can see in here, I've now got a list of logon events, and you can see Active Directory logon events, interactive logon events for, sorry, I clicked my mouse by accident, for that user, Steve, across predominantly this Windows 10 B device in the environment there. So I get, quite a lot of detail about those logon events. I can also summarize this as well if I want to. So I could say summarize count by, I could do account UPN and then do comma device name. So then that's going to give me, and I think it would be all the same device. Oh no, I've got different devices here. So now I can see actually I've got 1,618 logons against this Windows device here for Steve, 35 for this user here, and 13 for this user here. So it's really powerful to start to filter and look at that information. So in the next sort of 10 minutes, I want to show you, it's going to be a quick fire view of this, unfortunately, just in the compressed time we've got. But I want to show you a couple of cool queries that are interesting for us. So in this one here, I'm looking, I'll just rerun it again. I'm looking for all logon events in the environment where it's either NTLM or Kerberos as the authentication protocol, and I'm going to summarize it by the count. Now, what I can start to do is I can start to chart this thing as well. So I can see that actually in this environment, 99% of my authentications are actually Kerberos-based authentications, and only 1% are NTLM. Now, that's actually pretty good, right? In a typical enterprise environment, that NTLM authentication is going to be probably significantly higher, right? So that's useful for me to identify if the NTLM authentication was significantly high, then it might mean for some reason that Kerberos is failing, it's falling back to NTLM. There could be a myriad of reasons why that is the case. So what I could actually do is I could go into that same identity logon events table, and I can search for all of the failed Kerberos authentications, and then I can summarize them by the failure reason. Now, if I just run that again, is it gonna, oh, there we go. I can see here that I've got a number of different failure reasons that have been identified. And again, I can chart it if I want to into a pie chart. And I can see, overwhelmingly, the reason for failure is because the account is disabled. Well, that's not going to fall back to NTLM in that instance, right? The user's just not going to log on. I can see there's a wrong password, unknown user, or an old password. So they're typically not reasons why I would be falling back to NTLM, but there are, maybe specific Kerberos failures where, encryption type not supported, maybe that it might lead me to then fall back to an NTLM based authentication. So, this is really useful for me to start to, to chart different use cases within the environment. This is more for operational needs, I guess, than security analyst needs. But, I think you can use both. You have both use cases that you can address with the hunting that we have here. I can actually look for all of the encryption types that are in use in the environment. Now, in this environment, it's all AES 256, but again, I'm looking at the Kerberos authentications where it's an interactive logon. So I've got the encryption type listed, and I'm going to summarize by the count by encryption type here. And I can see I've got 1,836 authentications, which are all using the right encryption type. Now, if I had a number of DES encryptions, heaven forfend if DES was in there, or RC4, that might be something that I want to go and address, right? That might be something I want to go and fix, identify what the root cause is, and of course I can see within the tables I could filter to show only specific devices that are doing RC4 based encryption. It could even indicate an attack where the attacker is trying to do like an encryption downgrade as well. So these are ways that you can use those types of tables there. I can also do things like look for failed logons, where in this particular instance I'm looking for where it's an unknown user. So somebody's trying to log in where they're trying to log into a user that doesn't exist, which might indicate some sort of recon or brute force style attack. Now, we do have detections for that out of box, but if you wanted to write something a little bit more custom, a little bit more honed, let's say, for your environment, then of course you can absolutely do that. I've set the limit here to 10 because I've not actually got that many in my environment, but you might set that to 100, let's say, or to a different number. And you can see here that I'm just going to search for all of the logon events. I'm going to summarize those events, and then I'm going to look where that summary number is greater than the number that I'm specifying here, which is 10. So I've only got one device that's seeing those particular unknown users there. Okay, what I want to show you, actually, I'll show you this one first. What I want to do as well is just show you that we have quite a lot of data in our Entra ID tables also. So all of the sign-in data across Entra ID is also surfaced into the sign-in events beta table. Some of it also goes into the identity logon events table as well. So there's a little bit of sort of overlap there. But specifically in this events table here, there's all of the cloud-based authentication. So there's quite a lot of detail in there. Now, what I'm doing is I'm looking over the last 14 days to look where we have sign-in events from a user which is classed as being disabled, which is based on this error code here. And then what I want to do is I'm going to summarize the information, and then I'm going to provide a visibility of the applications that user has been trying to log into, and the number of events, the aggregated events across that as well. So you can see here there's an IP address in question, which is being used to by this user Cam in the environment here to log into a number of different applications. So you can see Office, Edge, Windows sign-in, etc., with a number of failed attempts. Now, this user account has been disabled, so that might indicate that an attacker is trying to enumerate accounts. They're trying to log in with that account. It's again interesting artifacts for us to look at. So I just wanted to quickly just touch on the fact that we have quite a lot of visibility into the Entra events as well, into all of the logon events there. What I want to show you next is which one? This one here. So we looked at the user's timeline a second ago, and we saw in the user's timeline that there was a list of activities in the timeline. What this hunting query is actually going to do is it's going to interrogate that same data, that same activity data for the user, and it's going to then summarize the data in a way where we can see the number of different activity counts against each activity. So I've just specified a couple of variables here in terms of the dates that I want to search for. So I want to search over the last 7 days effectively, and I'm going to search for this user Sonia in particular. Now Sonia, of course, was the user who was part of the incident we were just looking at. And I'm going to look in the Cloud App Events table. I'm actually going to remove search events because these are really noisy. So I'm not interested in the search events. And I'm going to filter the output based on the last 7 days and where the user is Sonia. And then I'm going to summarize the data in a way that's hopefully meaningful for me. So in here, I can see a number of different activities this user has been doing, what the sort of object name is. So the object name would be something, a piece of information that's surfaced as part of the API. So in this particular instance, we've got a create event here for Microsoft Exchange Online. That's to create an email. The object name would be the name of the email in question. So account plan automation. I could grab that email name and I could go and search for that in the email events table as well. So you know, that's how we can start to then pivot across, you know, some of those other workloads as well. But you can see here I've got, you know, a number of activities for many different things, and I've got also that inbox rule that we were looking at earlier on as well. You can see that one's listed in the table here for me to look at. So again, you know, really interesting ways that I can look at the user's activity data. Now maybe there's one more that I want to show you because we are running up to the time, but this one's quite interesting, I think. We spoke on Tuesday, last week, about exposure management, and exposure management being sort of part of our prevention capabilities. Part of what that does is identify critical users within the environment and critical assets within the environment. So what I can do is I can actually leverage, and it's a little bit verbose, this query, but what I'm actually doing here is I'm identifying critical servers within the environment, or critical machines in the environment, and critical users. So users who are classed as being you know, critical because they're in a privileged group or whatever. And then what I'm going to do is I'm going to identify all those critical servers, identify all those critical users, and then I'm going to look in the identity logon events table, and I'm going to look for logon events where the critical users are not logging on to critical devices. Now, why that's interesting is because if I've got a tier 0 user that's logging into a non-tier 0 machine, that's something I want to identify, right? Because that could be credential exposure of a domain admin or an enterprise admin on a lower tier host. So again, this is how I can start to sort of build this out and look for you know, specific types or classes of users based on their criticality, and then identify where they're logging into those non-critical assets. And you can see here I've got a number of logon events for the Steve user to this Windows 10B device, which is basically a non-critical asset. So that would be something for me, interesting for me to investigate, because you know, that's not classed as a critical server for any reason, and that could lead to credential exposure. And actually, we do have an incident that we do run in this environment which does exploit that fact. So yeah, that's definitely interesting for me. And again, with the I did say one more, but I'll just quickly show you this. The exposure management also has details about the groups that a user is a member of as well. So if I run this one here, I can actually just look specifically for users who are in domain admins or enterprise admins as an example, and I can see I've got a number of users here listed. Now we do have that sensitivity tag that I spoke about, but actually I can look in the exposure management stuff for that, and again I could look for logon events where that would be interesting. So with that, appreciate I sped through that quite quickly, but hopefully it was useful. And I don't know if there's any final questions, Heike, before we close out.
There's actually two questions that I would like to bring up. So the one is, for now, you showed all these queries. Are they somewhere saved and shared anywhere, or could we share them somewhere?
So most of them, and I've just gone to the page, my good friend in France, Daniel Pasquier, who's in the French Microsoft team, he's got a great GitHub repository here, which has got a lot of the queries in there. We also have our advanced hunting documentation and other stuff there.
Can you send the link to the GitHub so we can put it in the published answers? So, yes. And then the other question was around the Office part that you showed. Yeah. The question is, you know, when you see that sign in page, would there be a link to this suspicious URL somewhere embedded in the sign in page URL? That's an Office question.
So, sorry, can you say the question again? So would there be a link?
Is there somewhere that, because in the end, the sign in is a suspicious, it points you to a suspicious URL. So is already that suspicious URL somewhere embedded in that sign in page that you are going to?
If I understand the question, what we the way that we perpetrate this attack scenario in the demo environment is we have a set of redirection URLs. So when we send the email, it's actually a redirection URL that lands in the user's mailbox, and then when they click that through, they get a 301 redirect to the malicious URL, which is where we host our pseudo phishing page, which we then use for the credential phishing. All of the detail about the URLs and the URLs that are redirected to and from are in the I just didn't dig into it too far. They are in the detections. There is a huge amount of data in there around what those URLs are, and it's all in the hunting tables as well. So there's a whole host of information about the URLs, the URL click events and such in the email tables where that's relevant, or indeed in the device tables if it's coming from an endpoint specifically as well.
Okay, so anonymous, because there's no name, if that didn't answer your question, so you can send me an email, Heike Ritter, hritter@microsoft.com, and I will try to get the answer from the Office team, because I think, So, Chris, it's been the third webinar. Thank you so much for being our guest and for sharing this really great information. People really liked it. And of course, thank you to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners that are still on the line, if you are someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Today, together we can make a global impact. So join us at aka.ms/security community. This is also where you will be notified about the upcoming webinars, events, and other announcements. This is also where you can find the recording of the sessions and the slide decks presented. Also, please take a minute submitting your webinar feedback, because this, of course, will help us make our webinars better and listen to your feedback. For those of you who may have additional questions on the topic we just covered and other product-related questions, please feel free to raise them in our Microsoft Tech Community discussion space at aka.ms/mdi-community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time, which is it tomorrow? Yes, hopefully see you all tomorrow for the last part. And with that, thanks everyone.